Hello there. Today we are about to embark on a great safari of knowledge. We shall witness on hand the dangerous and never before captured on film plant competition interactions. Luckily, you have me, JP Grime, as your guide. We will venture into high productivity environments, those with the greatest potential for plant growth, as I, JP Grime, believe the site of all competition. At high productivity, competition prevails, and the best competitors ruthlessly exclude the poor competitors from existence. At low productivity, I expect that we would see none of these competitive interactions that I will be showing you today. The competitors simply cannot survive in the harsh environments. Only the plants, which are the greatest stress tolerators, will persist.
Excuse me, Mr. Grime, but I believe that competition is an important factor in every environment, independent of soil productivity. Competition does not vary in quantity, only quality. Your safari would be incomplete without looking at competition in low productivity environments.
David Tillman.
Yes, I'm David Tillman.
My dear Mr. Tillman, I beg to disagree with you, as this is my show. I will continue on explaining to our audience my theory on what we are about to see today. Here we have a very stressful, low productivity environment. Here we have a different extreme of evolutionary constraint, a low stress environment with high productivity. Each end of the productivity gradient poses different evolutionary constraints to which organisms adapt in response. Good competitors take away nutrients, light, and space from poor competitors. Here, we see this in action. Assuming these competitors weren't there, the stress tolerators would be able to happily live there. This is their fundamental niche. But unfortunately for them, the competitors exclude them, constricting their range to their realized niche. That poor chump. She's on the losing side of competitive exclusion. A good competitor might allocate their resources to large leaves and tall stems in order to maximize growth and intercept light from the poorer competitor. A good competitor might also be adept at pulling nutrients from the soil such that poor competitors would not be able to get the nutrients that they need. See here that in a stressful environment, plants are good at conserving resources and thus tolerating the low levels in the soil. Good competitors cannot survive in a stressful environment, so stress tolerators live a life free of competition.
Please, sir, can I have some more? Please?
Traits that would make good stress tolerators would be slow reproduction, slow growth, and good conservation of resources. Because the phenotypes of stress tolerators and good competitors are adapted due to two different extremes of constraint, stress tolerators cannot be good competitors, and vice versa. A good competitor, as you see, is a good competitor in all environments.
Stop. I'm commandeering this nature show. You have it all wrong. Again, I'm David Tillman. Now understand, competition remains an important factor everywhere along the productivity gradient, but the way competition is realized varies. The competition is different in stressful environments than in highly productive environments. Primarily, in a productive environment, the competition is concentrated above ground, while in a stressful environment, the competition is concentrated below ground. The different types of competition still provide different constraints, which leads to different allocation of energy and resources in growth and high productivity and low productivity environments. If we move slowly, hopefully we can witness these interactions firsthand. Here's a high productivity environment. See here, in an environment with high soil productivity, there is more allocation to the shoots and leaves because the competition is realized above ground for light and space. Here we see it, the competition occurring below ground. In a soil with low productivity, there is more allocation to the root system because that is where the competition is realized. This is because a low productivity environment often has low levels of nutrients, which the plants must compete for.
I have a huge root system.
While Mr. Guy might argue that competition is a uniform trait and good competitors will always be good competitors, I disagree. There are no uniformly good competitors. Good competitors in high-stress environments are poor competitors in low-stress environments, and vice versa. This is due to the evolutionary trade-off in their adaptation to their respective environments and has been supported by experimental evidence.
Hey, my theory has a lot of experimental evidence to support it as well. Weren't you watching before? Give me that. Give me that.
Tillman, Grimes, stop! Both of you have a flood of experimental evidence supporting your theories. That's why this debate has remained a hot topic in ecology. First of all, your theories have more in common than you're acknowledging here. You both agree that concentration of limiting resources is directly related to competitive ability, but it's more likely that individuals will have different uptake rates of different resources. This is Tillman's resource ratio hypothesis. Because you don't consider the resource ratio hypothesis, Grime, you believe good competitors are always good competitors, while Tillman, you believe that there's a trade-off in competitive ability, and a good competitor in other environments might not be a good competitor in another.
Ha! I win.
Not quite. Neither of you can completely predict competitive ability along a productivity gradient. One thing to consider is that both of you believe stress to be completely correlated with productivity. This is not always the case. For example, in salt marshes, tidal stress can cause anoxia and waterlogging. These stressors limit plant growth and create a stress gradient in the environment. In low productivity soil that had this kind of stress, there was no competition, which would support Grime, not Tillman.
No, I win.
But when transplanted to fertilized environments, the best stress tolerators were also the best competitors, supporting Tillman, not Grime.
Sucker.
Will you two ever stop fighting? There are also other strategies to be considered. Facilitation is an interaction which is beneficial to one species with a benefit or no cost to the other.
Here, have half my sandwich.
Plants do not always have completely negative or completely positive interactions. They can have both competitive and facilitative interactions at the same time.
Thanks for the sandwich.
You're welcome. Now get out of my space!
The argument for facilitation states that competition remains essentially constant along a productivity gradient, but that there are more facilitative interactions in low productivity environments. This would mean that the total negative effects of plant interactions are less in a low productivity environment, as Grime expected and observed, but that these negative effects are due to less facilitation rather than more competition, which would not support Grime's theory. Tillman did not consider facilitation either. Without considering facilitation, it is difficult to measure competition. So while sure, Tillman's theory is more applicable, you do not account for facilitation, so there may be cases that your theory will not be able to explain competitive interactions.
Oh, facilitation. I never thought of that before. Thanks.
Although neither theory can completely predict competitive ability along a productivity gradient, Tillman's theory appears to better account for what happens in the real world. It's a tough world out there for a plant. If the stress doesn't get you, the neighbors will.
For a plant to stay alive, it needs 5 things I would not lie. It needs water so it can grow. And it needs soil just like so. Plants need space, they can't be tight. The sun helps plants by giving light.